Okay, thanks everyone. This is Stateless Implementers call number 35. I will share the agenda in the chat. So as a brief summary of the agenda, we have the usual team updates. We have some last minute cancellation of the presentation that Hans was going to do, and that will move to the next call. Then Carlos wants to discuss a bit about this FATNet network that we are planning to do to gather some metrics, but I let him talk about that. Then we have a follow-up on EIP 7748 regarding some special accounts that we have some custom rules about how to convert them. Then we have this EIP 7612 and we have to discuss some rules about how to handle 7702 delegations there. Then we have a follow-up on a topic that we discussed many SIG calls ago about the atomicity of gas charging in 4762. And finally, we have also for that EIP some discussion regarding access lists. So yeah, let's start with team updates. I can start as usual. So from my side, I've been working for a while on some refresh on bytecode chunking in general on the protocol level. Most people here already know that code chunking is already part of EIP 6800. But I wanted to do some kind of refresh of like what this problem about for the community and our potential solutions. Mostly motivated on some later sentiment on some people, on maybe being less aggressive with protocol changes and just thinking about which are other options and different trade-offs. So this article was published last Friday. I will share it in the chat if anyone is interested. I don't think it is worth maybe presenting this in this call because I think most people here are already quite experts on this topic. But yeah, the idea was to open the discussion for more people to be aware of this problem. And I've been also helping Kev on some worst case scenarios benchmarking for CKE VMs, which are mainly the same worst case scenarios as for any kind of proving system in layer 1. So yeah, this will help to understand better the potential challenges on these other kind of potential stateless solutions. Yeah, that's mostly it from my part.
Yeah, I guess I'll go. I was working mostly on getting PRs into Geth. Now I'm waiting for them to be reviewed and merged. So I'm gonna stop for now because yeah, there's already like five PRs awaiting review. Otherwise, I was also working on trying to rebase nonetheless, rebase Geth. Rebase the Kalstinen with Chapella branched onto let's call it Kalstinen with Spectra. Yeah, that's ongoing. And otherwise, yeah, there were some spec rewrites, but I called in Guru for help. So I guess we're gonna discuss that this week, I think. But yeah, like the goal is to rewrite EIP 4762 because it's quite unreadable, frankly. And then on top of that, we want to add 7702. So there was some investigation on 7702 that needs to be added to that EIP, but we're going to do everything at the same time because, like I said, the old format of the current format of the EIP is pretty ugly and unreadable. So we want to revamp it to add 7702 there. Yeah, there's probably a ton of other things, but that's the main stuff.
So I guess I'm gonna go next. From my side, I've been mainly trying to work on two things in particular related to the testnet that the people from Nethermind have put out recently. The idea is mainly to try to recreate a similar thing, but we actually explore state growth limits. I'm trying to do two things. The first one is assess the data that we want to collect. So basically, there's a bunch of data that we can just collect from the chain history, but there's a bunch of other data that will just get evaporated if we don't collect it on time. So for instance, RAM performance, anything related to networking, and I don't know, not particularly interesting in any case, but mempool data could be another good example of that. So the idea is to try to see which is all the data that we can collect. Behind the scenes, the goal is clear. If we want to ship statelessness, we definitely need to know with which urgency do we need it. And with the EIP that Dankrad filed a few days ago, proposing to arrive to 100x, if I remember correctly, the gas limit, it would be interesting to see where clients actually break because they cannot hold the state anymore, when hardware upgrades are needed and all that stuff. So for that, I've been working on Spamor, the tool from ETHPandaOps. And basically, I've tried to compile the cheapest ways to include state or to make the state bigger on Ethereum on a gas per byte level. And I've been writing the scenarios for that to bombard the network. And on another side, I'm trying to work on an application that allows us to replicate a more realistic state growth, replicating mainnet transactions mostly and trying to block the state by 2, 3, 4x, whatever we need. So that's basically it.
I think I can go next. So on the Nethermind side, I completed the rebase on Pectra, and now I am merging the transition code in it. So this week I'll finalize those changes, and then I'll start working on the binary tree implementation.
On Bezos side, I was able to also rebase Verkel with Spectra. So thanks to that, I was trying to do a migration on Hoodie. I'm not able to validate the state root we are generating for the moment, but just to see how the current code is working when we have to migrate some leaf for each block. Thanks to that, I was able to fix several issues in my transition code, and I also saw some performance issues during the stateful computation when we have a lot of leaf to migrate in the tree. I'm trying to do some optimization on this part, not a lot because maybe the cryptographic part will be modified in the future, but yeah, a minimum kind of modification. And yeah, still working on that. I still have some issues to fix. And on the stateless part, so Thomas, I don't have the last update, but Thomas is still working in the stateless part of Bezu and mostly regenerating the tree from the witnesses and proof.
Anyone else has some update to share? Okay, so let's move to the next item in the agenda, which is data collection points for FATNet. Carlos already touched a bit on this in his update, but I will let him explain maybe again what is FATNet and what is the goal here.
Yes, I'll be very quick. Nethermind basically, as you might know, set up some PerfNet a couple of weeks ago. They did an amazing job, and basically they were trying to see how big of a block the network is able to handle. The idea is to create a similar network or a fork of it or something like that, where we can actually specifically target the state growth metrics and state growth as an issue to see how much the network can handle when things break, and to collect as much data as we can that we find interesting. So in order to do that, I've put up this HackMD. I've already added up some stuff that I had or the team mentioned that I think would be interesting to collect. I would invite you all to basically add anything. Everyone has edit rights. So please share it with anybody that you think can have any ideas or will have will have some valuable insights of what data will be interesting to collect. Basically, it's expensive and hard to run these things, so we will not have many chances to collect this kind of data, and I assume it will be valuable to do so. So I invite you all to please collaborate and add any data points that you think are interesting to be collected. Thanks.
Is anybody already thinking about some particular metric that they think is useful regarding state growth in this kind of high-paced kind of devnets? If not, we can touch again in a future C call, but I know maybe already there's some idea here.
I think probably the first thing is sync breaking. Like we want to know what state size sync will break, or snap sync, I guess.
Yeah, that's a good point, and a point that Guillaume made too. So for that, I will probably chat with Patty, because since everything that includes networking is a bit tricky here, because we try to have not many machines, but those machines doing a bunch of work. And as to my understanding, snap syncing, there's a big component which is network and your view of the network. So I will chat with Patty and ask if we can have, I don't know, many more machines that don't do the same amount of work, but they are there to kind of hold or participate on this process. It will be a bit tricky, I assume, but yeah, I agree. It's useful information. Thank you.
Do you mean the work of generating the transactions?
Oh, no. I mean the work of supplying you like history to put it on some way so that you can sync.
Yeah.
Guillaume?
Yeah, I was just thinking, like a client that tries to snap sync usually doesn't have a lot of peers to download from, because they're still looking for it. And I think most clients, I forgot there's a cap for clients. It could be 20 or it could be 50 or maybe 100. But what I mean is we could create, if it's about creating 20 machines and spread them all over the world, sometimes in data centers, sometimes with just people running like a machine for us. It could be actually pretty easy to simulate, I think. Okay, let's see what Perry says. But I think even with 20 machines, it would not be too hard to figure out what it takes to download, to snap sync the state. Another thing I wanted to mention is that to test the snap sync, you actually need traffic, right? Because if your blocks are empty, then snap sync will not have a healing phase, and potentially that's going to be not very realistic. So we need like a lot of transaction touching different locations of the state to make sure that this is stressing the snap sync.
Thanks.
Okay, let's move to the next discussion, which is a follow-up from a conversation we have in the last call regarding skip some conversion of state in some particular accounts. So as a refresher, in the last call, we have some confusions about, okay, so originally the EIP 7748, which is the conversion EIP, said that whenever you find an empty account, you basically skip them in the conversion. But after some discussions, we already knew that these accounts do not exist in mainnet because they were already deleted by some action that Peter did some years ago, I think already. But we also knew that Gary was interested in other kind of accounts, so there was a bit of confusion there. So after the call, Guillaume kind of got more into the details and talked with Gary, and I think we now have a more clear picture of what we really want to do in the EIP, and he already did some changes. So maybe Guillaume wants to give a summary here.
Yeah, I just realized I should have prepared the EIP itself instead of the. But yeah, just as a summary, so the type of accounts that were not. Okay, sorry, I'm typing at the same time. I shouldn't be doing this. Let me share my screen. Yeah, this one. Okay, so to start. I don't know if you guys can see my screen, but to get back to this conversation, there was this EIP 7610 where it tries to delete or it wants to delete. Actually, that's not what it does. It's trying to avoid a specific corner case that would happen when. Okay, for this to happen, you would need a hash collision to begin with, so it's also not very likely to happen, at least at the moment. But in the long run, it turns out you do have accounts in the state that do have balance, right? And they have storage, but they have an empty code hash. And those accounts were not deleted by Peter Miller. So what we want to do, because it's effectively inaccessible at the moment, we want to delete them during the conversion. And the way we do this is by changing the spec. I'm looking for the line that was done. It's just checking if the account nonce is 0, but the account and the account code is 0. We just move to the next to the account conversion phase. So we skip the storage conversion, and this way, if you do have an account as described in 7610 that is basically an EOA with storage, you will not convert this. There's actually, I realized saying this, a potential issue with 7702 exactly accounts, because if they get deleted, if there's a delegation that happens, some code that runs, storage slots being created, and then the delegation is deleted, we lose those things. So in my view, that's fine, because we are still having an account that is not like that has storage that cannot be accessed, but it could be accessed in the future. Oh, right, that's true. The nonce is not 0 in that case. Good point, Karen. Yes, okay, that solves the problem, actually. So thank you for that. Right, so that's just what it is. There are some slots that we will ignore, and that's because they cannot be accessed. So yeah, that covers that is not related to 7702 is very good, and that's all there is. So I think Ignacio had a way to talk about those accounts that was nice. Yeah, it's an invariant. If an account has zero storage, as a non-zero, like non-empty storage and a 0 nonce, then it should not exist and will be removed during or will be cleaned during the conversion, because the account itself will be translated, but the storage will not. So it will disappear. Yeah, that's pretty much all there is to it, unless there are questions. I guess not. Okay.
Okay. Cool. Yeah, so eventually we should add tests for these changes. So I will make some notes to eventually cover these new scenarios. Cool. So the next discussion is about something that we kind of touched in the last call, but I think it wasn't entirely clear. So I think it's worth rediscussing now. So in the previous call, we were talking about some side effects of 7702, and at some point we discussed what will happen in the overlay tree whenever a 7702 delegation is removed, right? So let's imagine that we have an EOA, some 7702 transaction creates some delegation. When that happens, we need to write the delegation as the code of that EOA, and also update the code size, right, and the code hash. So the question is, whenever that delegation is removed, clearly we should change the code size again to 0 and the code hash again to empty. But there's like this question on if we really need to clear out the delegation itself in the code of the EOA or not really, because technically speaking, if you see that the code size is 0, you can assume that there's no code. But yeah, like my personal opinion about this is that I would prefer to clear out the code in any case, despite it might not feel entirely like needed, because I feel like it kind of keeps the tree a bit inconsistent. Because I know if I make a proof of the first chunk of the code of the EOA, I will see that there is a delegation, but actually that delegation doesn't apply because I will have to also check the code size. So I don't know. It's small. Like my opinion is mostly based on some more coherency argument rather than a strict need of doing that. So I don't know if anyone else has an opinion about it.
I do have an opinion that is contrary. Oh, was Tanish going to say something? Okay, maybe that was just a flicker on my screen. Anyway, yeah, my opinion was the reason why we should not is a bit trying to do some, keep things cheaper by not paying the gas, because if we change the value to 0, we have to recompute we have to add it to the witness, we have to recompute the commitment, and so we have to pay the gas for it, and that makes the operation that much more expensive, which is okay, fine. It's 200 gas, sorry, it's 700 gas. Yeah, it's just that the question is, I guess I'm going to contradict myself and change my mind. The other argument is that, yeah, some implementations that want to check for a delegation might go straight to the code hash directly, and decide, sorry, not the code hash, but directly the code itself. And if they see that the first byte is a delegation and they don't check the code size, that could be a problem. So actually, yeah, I'm changing my mind, and I agree that we should clear it, even though it's more expensive.
Cool. Yeah. Okay. So if that seems to have some consensus, we should probably, have this clarification in the EIP whenever we do the whole set of 7702 updatings in all the EIPs. So we leave this clear. Okay. Let's move to the next topic, which is talking again about this atomicity of gas charging. This is a topic that was discussed some 6 calls ago, and there was some testing that Guillaume wanted to do to really assess the complexity of doing this change in Geth and share that with the rest to really decide how to move forward. Maybe Guillaume, you want to continue on that?
Yeah, I'm just sharing my screen again, but it's gonna be very short. Here we go. So, like we said, I created an EIP. I still have some testing to do, but from what I can say, I can tell it's working very well. And it does simplify the code, the Geth code, maybe not significantly, but quite a bit. So it's always nice to have. So my suggestion would be to change the spec. I think last time everybody was more or less okay with it already, but I just wanted to follow up on this and say, yeah, it's been looked at. So one thing I would mention is that I did that branch and I tried running all the execution spec tests that we have, and out of the 530 and so tests, only 99 failed. I've started looking at them one by one. It's pretty tedious. So far, every single test I've looked at confirms that it's like the atomicity is why the test is failing. But yes, I'm gonna have to go through 99 tests to make sure that I didn't get into a corner case. But from what I can see so far, it's correct, or at least it's doable and it simplifies. So my suggestion would be for other people to have a look at it, because yeah, it's gonna take me some time to go through 99 tests. But yeah, from what I can say, it's worth that other clients implement it, and hopefully we can resolve this question fairly quickly. Yeah, that's pretty much there is to it. If you have questions, again, now is the time. Right, Tanishq was not convinced, but I think that was for a different reason, right, Tanishq? You remember?
Yeah. So my reason was that if we are uh like if you're charging gas, and in atomic conversion, what happens is, like, let's say you need to add 2 leaves and you don't have the gas for 2 leaves, but you're
Yeah.
paying for 1 leaf, so that 1 leaf should end up in the witness. That was my argument. But again, the thing is that, like, I'm not sure if that 1 leaf ending up in witness is useful to anyone. It's just that it feels like a more correct way to do it, because someone is paying the gas for that leaf, so it should end up in witness. But yeah, I think I'm fine now either way. I can try implementing atomic charging in Nethermind as well, and yeah, we can.
Yeah. I mean, it's true. It's a bit unfair. At the same time, like you said, no one is going to use it at all. Like, there's nothing you can do with that, really. It's making the witness that much bigger for no good reason. And yeah, it's like, if you have, I mean, the counter argument to this would be, for example, if you write an S, you do an S store, right? And you only have half the gas available. Do you write half the data? You don't, right? You just have to either you write the entire data or not. So I think making those things atomic, given the complexity of those tests we have to write, I agree it's a bit unfair, but it's not making any difference to the end user, except yeah, they don't see their pretty leaf in the witness, but that's it. So it could be a pain for debug. That's true, but yeah.
Yeah, I think it makes sense, but I don't think we will be able. Do you also want to do this for the code copy or Xcode copy hash codes, opcodes as well?
So in my implementation, and unless I made a mistake, that's exactly what's happening. So if you look, for example, at where is that going to be? Yeah, probably EVM. If I right, I have a to do, but yeah, at the moment, I actually don't. Yeah, I take that back. Yeah, I checked exactly. I do it I do it leaf. No, it's a touch code chunk range from 0 to right, exactly, right. So indeed, like for a code copy or even contract deployment, what happens is that I will not deploy any code, or if I can't get the entire thing. That's yeah, that's unfair. I agree, but once again, witness bloat and maybe how do you call that, consistency with the behavior of writing half a storage slot.
Yeah, that makes sense.
Yeah, I just want to say regarding the tests, yeah, definitely if we do this change, you must see some tests failing, because in the test, I actually had to cover all these like partial witness scenarios. Sorry. And since this was filled with this non-atomic charging, the test it is expecting some partial witness, right? So yeah, just maybe try to do some quick confirmation. That seems to be the case. Hopefully with the test names it should be pretty clear, but if not, I can help to double check if those are the right tests that should be failing. And if we do this change, the only thing that we have to do is to actually refill the existing tests and just like make a new release. Apart from the testing side, we have to actually explain this in the EIP, right? Because the EIP doesn't have any kind of explanation about atomicity of hash charging regarding the witness. The current style of 4762 is simply explaining, kind of individual additions to the witness. So yeah, this should be explained in the IP, maybe as part of this refactoring that we'll do regarding using Python for describing the rules or something like that.
Exactly, that was my plan, precisely because when it's going to be written in Python, you will have to make it super clear. So that's when it's going to happen. One quick question is, since you're here, 90, like those 99 tests, is there logic, when you've wrote all those tests and where they are, but they were designed specifically for failing on the boundary, on the leaf boundary, is there a logic for them so that I could maybe cross them out, like cross out multiple tests at a time and not go through every 99 tests?
Logic in which sense?
Like yeah, like are they grouped in the same file? Do they have this a specific name that I could use to I don't see a
I
pattern.
think I don't remember from the top of my mind if they're in the same file, but definitely with the name it should be pretty clear. But yeah, we can check offline, but it should be easy to identify them by name, I think. Okay, cool. So this basically means that apparently everyone agrees on doing this change. I just trying to make this clear because all BL clients will have to do some work around this. Yeah, so if anyone is opposed to this change, this is kind of the last call for that. Okay. I will still say that the conversion work is the most important part, I think, for now. But yeah, if in the background we want to do this change, probably it will be included in probably the next DevNet that we might plan. Cool. Okay, so the last item in the agenda is 4762 and access lists. So I will explain a bit this. So I was working on some other stuff, and I realized that 4762 doesn't explain anything about the relationship with the access lists. And what I'm referring to concretely is the following. So today, if you use access lists to warm a storage slot, you pay 1900 gas for that, right? So technically, with access lists today, you can warm up on a storage slot with 1900 gas. I was looking at Geth with 4762 implemented, and the way it works is that we basically disable all access list logic, basically. So that means that if someone sends that same transaction with access lists trying to warm up a storage slot, we won't charge 1900, and we will simply charge the new 4762 gas costs, which is 1900 from the branch and 200 for the chunk access. So this basically means that if someone is trying to use a storage slot through access list, they will pay more than today for that, and that means that we might be breaking some contracts. So yeah, I mean, since the IP doesn't clarify this at all, I think I wasn't sure if this was intentional or maybe it was a miss. But definitely we should make it clear in the IP. Yeah, Guillaume?
So I went through the history of all those things, all those updates to the EIP, and in the original draft there was a mention of access lists. But yeah, I guess that was me, or okay, I don't know how it got dropped, but it was definitely dropped. What I can tell you is that it wasn't saying much, but just basically one of the reasons why it got dropped for sure is because it was saying access list should be an SSZ, and that wasn't clear at the time. There was I think Ethan that was trying to push for SSZ type transaction, so there was a lot of visibility. So maybe that's why me or whoever did that change dropped it. So we could reactivate this. We should reactivate this, and we should implement it. I guess that's it. That was just some historical context.
Right. So I guess that the idea is to not really. This wasn't like an intentional drop of the charging, right? So we should probably add to the IP that whenever that access list transaction happens, we will keep charging those gas costs as usual, and in the EL client implementations, we should add them to the witness, right? That will be kind of the TLDR of the spec change.
Yeah, we still have to think about it because there was something you didn't do before with access list. Okay, so the initial access list mention, I went to look for it. It was not mentioning gas costs, whether they were disappearing or not. It was just saying access lists are SSZ based, and that's pretty much it. The question is, should we add the value to the witness? I guess we do, because we're adding the access list because we're paying the cost anyway via the access list. We should add them to the witness, but at the same time, the access list is going to be found in the block, so we could bloat the block for half the price, basically. I think we have to dig a bit more into this. Like we have to think more into this.
Yeah, I think we can also simply like maybe this is complicated things, but we can definitely warm up the cost and not really include it in the witness and just let the usual execution do the inclusion if that storage slot is ever accessed. That will be better for the witness size, because if you put the storage slot in the access list and you never actually access it, we are not blocking the witness, but I'm a bit more, yeah, it sounds a bit complicated to add this border case of like warming up some gas cost without including the thing in the witness. I don't know. I feel a bit more worried about that creating bugs, maybe.
Yeah, me too, because I'm not sure I got what you said. You say like if we put the access list, like if someone sends a transaction with access list, we would not add the thing to the witness, but then we still need to check that whatever was passed as the access list is valid, right? So we still need it to be added to the witness. Did I understand that correct? I mean, do I understand what you said correctly? And do you agree with my problem?
I mean, yes, like not including anything in the witness up front, even if it is in the access list, but just like keeping like some mark somehow that if that storage slot is accessed, the cold cost that we should charge is access list cost and not really 4762.
Yeah, but that's where I don't think that's gonna work, because when whoever reads the access, like the cost, whoever re-executes the block to validate, they're gonna have to go and check that what's in the access list is indeed what is presented. No, wait, they don't have the value. They don't have to go and read. Yeah, true.
No. Like they just have to keep in mind that whenever a storage slot is accessed, they have to check if this is in the access list, and if that's the case, instead of applying 4762, they simply apply whatever the access list EAP said. Just that.
Yeah, true. Okay, I think what we should do is have a spec update, proposed spec update, and see if people agree. I don't know if anybody else has an opinion on this, but I think it's actually something that was in our blind spot that needs to be dug out. Yeah.
Cool. Yeah, I agree. Let's do like some kind of spec proposal change, and we can discuss it in more detail and more clearly maybe in the next call, and we can check that everybody agrees on that. Okay. This was the last item in the agenda. We have around 15 minutes left. I don't know if anyone wants to raise some other point. Feel free to do it. No? Okay. So we can finish earlier. Yeah. Thanks, everyone, and see you in the next call.
Cheers. Bye-bye.
Right.
Hey.